Let's talk about a problem that's almost definitely happening in your home and office right this second. It's a kind of electrical noise, and it's a growing issue for the power grid we all rely on. So let's dive into what it is, and more importantly, what we can do about it. When you plug in your phone or your computer, you just assume you're getting a steady, clean flow of electricity. But what if I told you the power coming out of your wall is actually, well, dirty? So ideally, the electricity coming from your utility should look like a perfect, smooth wave. But a lot of the time, it looks more like this, all jagged and distorted. And this isn't just some minor imperfection. Oh no, this is a really serious problem called harmonic distortion. And trust me, it can have some major consequences. So what exactly is this electrical noise that's messing up our power? It's time to pull back the curtain and get to the root of the problem, something called power harmonics. Okay, here's a pretty simple way to think about it. The power grid runs on a fundamental frequency. Here in North America, that's 60 hertz. I want you to imagine that as a perfect, pure musical note. Now, imagine someone else starts playing a bunch of clashing, dissonant notes right on top of it. That beautiful sound gets all garbled and distorted, right? Well, that is exactly what's happening to our electricity. Harmonics are just those extra unwanted frequencies that corrupt the main one. And this visual just breaks it down perfectly. See that smooth blue line? That's the clean power we want, that pure fundamental 60 hertz wave. But then, when you add in other frequencies, like the third and fifth harmonics you see here, they create that messy, distorted red wave. That, right there, is our dirty power in action. So where is all this distortion even coming from? Well, the source might be a lot closer than you think. In fact, it's probably happening in your office or maybe even your home right now. The culprits are what engineers call non-linear loads. And as you can see from this list, they are literally everywhere. We're talking about your PC, the office printer, the entire server room, heck, even the HVAC system. These devices, they draw power in these short little bursts instead of a smooth, continuous flow. And that's what distorts the clean electrical wave. And here's the real irony. The very devices that have made our lives so much more efficient are the exact same ones polluting our electrical grid. This isn't just a problem for big industrial factories anymore. Every single modern office, and more, every home is a source of this harmonic noise. Now, this might all sound like a minor annoyance, but these harmonics can cause real physical damage to our electrical infrastructure. Let's dig into why this dirty power is such a massive problem, causing everything from overheating equipment to, catastrophic failures. Yeah, the consequences are no joke. All that extra harmonic energy has to go somewhere, and a lot of the time it just turns into heat, causing cables and transformers to dangerously overheat. It makes sensitive electronics act up, it trips circuit breakers when there's no obvious reason, and it can even cause neutral wires, which are a critical safety feature, to fail completely. And then there's resonance. And this is where things get genuinely scary. Think about pushing someone on a swing. If you time your pushes just right, at the right frequency, that swing goes higher and higher and higher. Well, harmonics can do the exact same thing to an electrical system, creating a resonance that can wildly amplify currents to absolutely destructive levels. The good news in all of this is that we are not powerless against this problem. Not at all. Engineers have developed some incredibly clever solutions to fight back against this harmonic distortion and, clean up our grid. There are really two main ways to tackle this. You've got passive filters, which kind of act like drains. They give those nasty harmonic frequencies an easy path to ground, keeping them away from sensitive equipment. They're simple, but they can be a pain to tune just right. And then you have active filters. These are the high-tech option. Think of them like noise-canceling headphones for your power line. So how did those actually work? It's a brilliant three-step process. First, the filter senses the distorted current. Then, it generates a perfect mirror image, an anti-noise current. Finally, it injects that into the system, and what happens is the two opposite waves just cancel each other out, leaving only the clean power signal behind. It's awesome! And here is the beautiful result. That top waveform, that's the problem, the distorted current. The wave in the middle, that's the anti-noise solution coming from the active filter. And the bottom wave, look at that. That's the beautiful, clean result we want. It's just such an elegant solution to a really messy problem. So, as our world keeps filling up with more and more electronic devices, from IT gear to motor controls, managing the harmonics they create isn't optional anymore. It's absolutely essential to prevent system damage and keep our entire infrastructure reliable. And all of this brings us to a really critical question for our increasingly electrified future. With the rise of EVs, giant data centers, and smart homes, the challenge of harmonics is only going to get bigger. So the race is on not just to generate more power, but to make sure that power is clean. The real question is, will our solutions be able to keep up?